Hey people, and welcome to Math Sci Corner. In this video we shall be talking about one of the key topics which you shall encounter before you step into the world of linear algebra. So this topic is about how to solve a system of linear equations which have a lot of variables. Now, back in your school days, you have probably seen equations somewhat like this, which had probably two variables and two equations. Now, these were easy to solve. You could just do your processes of elimination and substitution, and you would easily get your x and y values. However, if you have a system of linear equations, let's say with n number of variables and different coefficients associated with all of those variables, then you would face some problem. So this is a system of linear equation with n variables and n corresponding equations. However, when the n value is higher, then it becomes quite difficult to solve with elimination and substitution. Now, mostly, another method which you may have encountered of solving such linear equations is the matrix method with the equation Ax is equal to b. Here, the A is a matrix of all the coefficients of the variables, and B is just a matrix of the RHS. So let me write this down for old time's sake. Now, if you watch closely, it is just the system of linear equations which is written above. You may have seen this in your school days. Now, what we did in this method is usually finding the inverse and then a lot of calculation. It was quite a long method, but we could get our work done. However, now we shall be solving the system of linear equations with Gaussian elimination method. Gaussian elimination method. And this is probably by far the simplest method of solving linear equations till now. So what we do in this method is that we follow a couple of simple steps. And the first step of solving is to write an augmented matrix, then carry out elementary row operations, and just putting back in the variables and writing out our solution. I know, sounds a little complicated, but let me show you with an example. So here we have a system of linear equation with three variables and three equations. And we need to solve the system by Gaussian elimination method. So I'm going to write down all the steps and solve it along the way. So our first step is to write the above system linear equations in augmented matrix form. In augmented matrix form, and this form looks somewhat like this. We simply write down the coefficients on the left hand side, and we put a bar in the middle and write the RHS on the right hand side. And on this augmented matrix form, we will carry out elementary row operation. So here's our next step, which is carry out elementary row operations. And we will carry out elementary row operations to reduce this augmented matrix which we have here into a row echelon form. A row echelon form. Now, what is this row echelon form? Well, here's how the row echelon form looks like. We will reduce these, we will reduce all the coefficients into zeros by our elementary row operations, and we will create the zeros in such a way that the first non-zero coefficient of each row keeps moving its position to the right. So let's say we have our first non-zero coefficient here. Let's call it A. And we have our first row like this. And then our next non-zero coefficient has to be here or can move more towards the right, and there must be a zero somewhere here. That is, we add zeros in such a manner that it forms a right angle triangle. A right angle triangle somewhat like this. Or it can also be like this, or it can also be like this, depending on the number of equations we have and how we are carrying out our row operations. And of course, this row echelon form is not unique, because we can find out the row echelon form in several ways. Some may take 4 steps of row operations to find it out. Some may take 3 steps to find it out and use different techniques. And now back to the discussion of non-zero coefficients. Our non-zero coefficients will keep moving somewhat like this. And this is what our augmented matrix might finally look like. And now the question which may arise is why we do this? Why are we finding out this row echelon form of the augmented matrix? Well, watch closely. If we have a form somewhat like this, then we have the coefficient of z, which is equal to the RHS, and in the second row we have the coefficient of y and z, which is equal to the RHS, and in the first row we have all 3 coefficients. That is, we can directly get our z value from here. We can directly just do back substitution and get our z value here. And we can substitute the z value in the next or second equation, and we can get our y values. And therefore, just with back substitution, we can find out the values of our variables, and therefore we can get our solution. So this is what we will do in this Gaussian elimination method. Now let me show this with this example. Okay, so now we are set to find our row echelon form with those desired zeros. Now let us start. So the first thing is that I'll just write out my matrix again. Here I go. And we will put R3 as R3 minus 2R2. I hope you know what row operations are. If you don't, it is very simple. It is just that we are manipulating the entire equations as whole entities. That is, we are manipulating all 3 equations. We are multiplying constants with the equations. We are subtracting one from another, and we are doing this so that our equations get reduced in simpler forms. That is actually what we are doing, and the matrix form helps us to do that, and that is why we have written it out in this form. So let's see what we get. This is our first row. Our second row stays the same. In the third row, it is R3 minus 2R2. That is, it will be 2 minus 2 times the x coefficient of the second row. So this is what it will give. It will give a 0 here. We have already got our first 0. Then in the second place we'll have 3 minus 5 into 2, 10. That is 3 minus 10 minus 7. And wait, let me write it in white just to make things clear. Minus 7. And in the third place we will have 1 minus 4, which will give us minus 3. And we'll have 0 minus 6 into 2, 12, which will give us minus 12. Okay, now let us carry out our next step. Let me now multiply the second row, that is R2 is going to 3R2. I'm multiplying constant 3 with the second row. First row stays the same, second row becomes multiples of 3. Here I go. And the third row, oops, let me put the 0 in the same blue color. Third row remains the same. Now we are subtracting R1 from R2, that is, we are transforming R2 to R2 minus R1. And let us see what we get. R1 remains the same. R2, here we will get another 0 because it is 3 minus 3. In the second place we'll get 15 minus 1, which will give us 16. And in the third place we will get 6 minus 1, 5. And then in the fourth place 18 minus 2, which will give us 20. And we already had our 0 there. And let us write down a third row which stays as it is. Okay, now let us go to our next step. So now we will transform the R3 to R3 plus, watch closely, 7 by 16 R2. This is just to get the coefficient 7 on R2 in the second place so that we can get another 0 and we can get a row echelon form. So here's what it will look like. R1 remains the same. R2, here's our 0. Here's our 16, 5, 20, everything's the same. In R3, there's a change. This remains 0 because 0 plus 7 by 16 into 0 gives 0. Then in the second place, we will have minus 7 plus 7 by 16 into 16, which will give us minus 7 plus 7, and it will give us another 0. And in the third place, we will get, okay, let me write this out for ease. 35 by 16, that will be 48 plus 35 by 16. That will give us minus 13 by 16. And in the fourth place, we will have 140 by 140. Wait, let me write this down too. 140 by 16 minus 12, which will give us 140 minus 192 by 16, and that is 52 by 16. Okay, we have got pretty good numbers here, so let me simply do back substitution, and that is our third and final step. So step 3, use back substitution to find x, y, and z. So here we go. Let us simply write out our equations now. 3x minus y plus z is equal to minus 2. Then 16y, because here's a 0, it is simply reduce our x to 0, and plus 5 is equal to 20. Then minus 13 by 16z plus minus 52 by 16, 0x plus 0,5, and that is equal to minus 52 by 16. So let us solve this. Let us start with this equation. This is just 13z is equal to 52. That will give z as 4. Let us substitute the value of z in the second equation. So this will give us 16y plus 5 into 4 is equal to 20, is equal to y is equal to 20 minus 20 by 16, which is 0. And now let us put both these values in the first equation. Here we go. And our first equation gives 3x minus 0 plus 4 is equal to minus 2, which will give us 3x is equal to minus 6 and x is equal to minus 2. So we have got all our three variables, and we have got our answer, our final answer, that is x is equal to minus 2, y is equal to 0, and z is equal to 4. So I hope you understood the Gaussian elimination method, and I hope you enjoyed this video. If you have any queries, please write in the comments and I will be happy to reply. Thank you very much and see you again in the next video.